Hi, this is Mark Weitzman. Welcome back to my channel, Theoretical Physics with Mark Weitzman. Today I'm just going to do a blog on what I've been doing for the last week. And mainly I took a few days off from group theory and physics, and I decided to try and do some catch up on some programming and everything. So, this is a site that I started a couple of years ago. I never really used it much, but I'm going to start redoing some things. And, over the years, I've done a lot of, too many windows on this thing. Over the years, I've done a lot of programming and everything. And, but I'm not a real programmer, even though I've done like beginning stuff with starting, like all the way back with Fortran and Basic and Pascal and then Scheme and Java and C++ and Python. And what I found was the problem is that physics changes very slowly. Not much new happens. A lot of new speculations happens, but the solid things, Newtonian mechanics and thermodynamics and classical field theory, electromagnetism, special and general relativity, quantum mechanics, and quantum field theory. They're all solid and they stay the same, and you know, so it's much easier in physics to keep up with things. Programming, if you don't do it for like a year or two, everything's changed. So I sort of gave up on trying to keep up with programming, but I did eventually settle on the Python language to do my programming. And the reason why is Python is a very easy language. It's become like a development language and the go-to language for things like scientific programming, machine learning. And when you finally get it working, yeah, you'll translate it to C++. And there's ways to speed up your Python programming so it has like Java and C++ performance. And I'll talk about that in a second. But anyway, this is my site, and I've got things like there was an MIT machine learning course that I took and some Caltech machine learning on their sites. Rutgers has a nice computational physics course that's like graduate level where you can speed up all your programs and everything worked. It was geared toward the Mac. It worked on Windows too, but it was harder to get it to work. And these are some current Caltech computational physics courses, just some links. And this was a book where I started really doing computational physics. Coonan's book. It's like 40 years old. It came out like in '84. At the time, it was unbelievable how revolutionary it was because he showed how to imagine how slow the computers were back in '84 using the basic programming language and then Fortran, and yet he did amazing things. And I'll show one of them. Quantitative finance, I'll add. I have some book recommendations and some resources and everything. So you might want to take a look at the site. Gradually, I'll add to it. Anyway, just to show you what I meant about like Koonan's book, you can get it online for like $10. Maybe one day I'll put it on there. This was the basic version. And, you can think of it as pseudocode today, but it worked and it was amazing what it could do. Later he came out with a Fortran version, and I'll just show you some things from the book. This is much more expensive. I would get the basic version. He has all the codes. He has about 8 examples and 8 projects, and they're very physics heavy, like sort of undergraduate, advanced undergraduate, some of them, a lot of things. I wish he listed all the projects here. He doesn't, but he starts with basic numerical analysis and then goes through ordinary differential equations. And he does a lot of physics, like on white dwarf stars and chaos and stability in the solar system. Goes to boundary value equations, solves the Schrodinger equation and everything. does all the stuff with Hartree-Fock. It gets pretty hairy with this complete solution of Hartree-Fock for small z atoms. And then he goes like special functions, and he does, elliptic and partial waves, quantum scattering, the shell model and everything, solving for phase shifts. So it's very physics. You got to have like a quantum mechanics course to really understand everything in this book. But then there are things. He does matrix things, and he solves like hydrodynamic problems and fluid flow problems. And he does the three elliptic, hyperbolic, and parabolic partial differential equations. Then he goes to Monte Carlo methods. He does the standard like Ising model. And then he goes into like some really interesting calculations of like some molecules using the Monte Carlo methods. He's got all the programs there, the complete code and everything. This is from the book. The programs are like old, and nowadays there are much easier ways to do it, but still it's good to learn some numerical analysis. It's good to do these basic operations and everything for getting random numbers, even though they're automatic today. But he does. He starts off slow with semi-classical things on vibrations and some models and scattering and everything, and then he accelerates throughout the book. Ordinary differential equations, and he goes to some chaotic differential equations. And I'll show you an example of like one of the programs that he does in his book. It's amazing that it could be done in 1984 very easily on a IBM PC. Order and chaos in two-dimensional motions. That's what I'm going to show you in a second. You get these like for non-chaotic orbits, and then for chaotic orbits, well, he doesn't have that page, but I'll show you in a second. Okay, here you get orbits like this when you take a section and everything. So it's very interesting, has a lot of physics. He shows the derivations and everything. I highly recommend this book, even though you might think it's 40 years old, is much better. I showed you this. Some points he discusses integrable systems, and then that picture I showed you. Just to show you an example now, I'm going to show you, hopefully this will work. I suspect a lot of things I'm going to show today are not going to work, but anyway, this was an example of like some two-dimensional motion in a potential. It's called the potential I showed on that other page. And in the triangle, he shows like where the motion is, and sometimes it's chaotic, it goes back and forth, and then it becomes non-chaotic. And this is like a section. Every time this orbit goes through a certain section, he puts a point on here. And, think about how slow this is running on I don't even know how fast this thing was, This is running, I took this picture, I just ran it. I don't have a Windows computer anymore, so I can't run these programs. But I have an old Dell laptop from 2002. You can see if you look over here, this Inspiron 8200 or something. And so this is running on a 2002 Dell laptop. And eventually you'll see the sections start to look a little bit like this. A little bit like what I showed in the previous picture. And but I just want to, it's like I said, he's got a lot of course, he has, I don't think he made use of color. Probably wanted to keep away from that. But what I want to do is to do some of these old programs again, to learn some of the materials on the quantum and everything, and update it and do everything in Python, where I can use the animation modules, the matplotlib modules, maybe even use a little bit of tkinter, however you pronounce that. And the main reason why I like Python is that it's easy to remember the code. Even if you don't code for like a year or two, it's such a simple language, and it's so easy to remember how to do things. You can make it complicated. And so I really like Python. I'm just going to let this run for a minute and a half while I talk. Anyway, nowadays this would all go in 1 second if I ran it on my Mac or something like that. It's thousands of times faster. But think about this. This is a 1984 program running. So there's a lot of interesting problems in the book, and I want to go through that. And try to. Okay, we got another minute. Matter of fact, I will stop this now. Okay. And let me go back to okay, Safari. So another book which I recommend, this is about 10 years old, is Computational Physics by Mark Newman. It's a pretty good book. It uses Python, and it's easy. And the main difference between this and Koonan's is Koonan's programs are like 500 lines, and these are like 20 lines, maybe some 50 lines things. But he goes for the basics for physics students. This is at like a sophomore level. And he's got a site where he has, you can download some sample chapters for free. And then he's got the programs and the data on there for that. And, oops, I'm sorry. He's got exercises and figures. So this is like a more modern version, but it's not nearly as good as Koonan's book. But it's a start, like at a freshman, sophomore level, if you want to start. Now, I've read zillions of books on Python, but every time I go back to them, I like to read another book just to, you know what, I didn't, well, let me just restart. Years ago, when I first started with Python, I used Eclipse, which is what I'd used for Java. Eclipse is like a professional IDE, and I finally, I got it to work with the pydev. I forgot. You have to incorporate that into Eclipse, and nowadays it might do it automatically. And it ran. All my programs ran, and Eclipse was very solid and everything. It was easy to use once I finally learned how to use it. And so I never complained about Eclipse. But it's got like a zillion settings and options and various things like that. I'm going to just try and show you right now. I hope this doesn't crash my OBS thing. Bear with me for a second while I try and get this on here. Okay. So this is Eclipse, the interface and everything. I don't have... Anyway, it's got some of these hard menus, but this is all my Python. It runs Java. I don't want to run a wizard. I just want to see the settings, but I don't remember how to get to there. That was my main problem with this thing. I never knew what 90% of this stuff stood for, and it's got everything you need, but it's too professional for me. I just like to let's say gives you code. You run your code. You can either figure out which green thing to hit here, and then it shows you in the console window. It doesn't show here. Let me so you see the answer in this console window. This is the Ackermann function, and everything works in this. You could do a visual Python thing, and it will open in a browser, and you could do Matplotlib, and it opens in a separate window, and everything seems to work with Eclipse. The main problem with Eclipse is the It's, okay, there it is. The preferences. They just go on and on and on with 18 zillion choices and everything. It's just hard to, I don't even know what 90% of these things are. This is PyDev. And then so many choices, so many things, if you ever like screw up something. So, but still, I got it working well, and I sort of became an Eclipse person. I didn't want to change it. But then eventually I went to Python, and the Anaconda is the standard. So this is the Anaconda when you install it, the Anaconda Navigator. And it's nice because it has separate environments, easy to set up for your. Nope, I always do that. I click on the wrong thing. Okay. So it's nice because it has like separate environments, easy to set up so that you can keep everything clean. This is like more for professionals than for me. It's got a nice learning tab. It teaches you can easily learn about all these things. It's got a whole community thing. It's the standard installation for Python, and it has all these things like the basic Spider IDE. Now the Spider IDE is something that everybody told me to use, and they said it's the best for science and everything because it has NumPy and everything. But whenever I tried to use Spider, it seemed to crash and everything. I just had difficulty with Spider for some reason, and one of the main reasons is that when you run, this is the Spider IDE, and it's pretty good. It's got debuggers and everything. It's much easier. If you go to the preferences, you'll see what I mean. Much easier. It still has some number of choices, but it's much more reasonable and understandable. And there's one thing in here that I didn't know about at the time, and this was crucial. I found out about this later, and they may have added it. When you go to the graphics thing, it's important if you have this like choice, and you have this inline where it puts it in the IPython console, or you have automatic where it treats it most of the time the way you want to treat it, and then it has like for Tinker, and so you have to set this right. Usually automatic is where you want it, but if you want to run a Tinker thing, you better set it on Tinker. So anyway, I just it's nice. Like here's an animation for an Eclipse which runs, and I have it, and it runs very nice. I'm not going to run it again because then it won't interact with the OBS, but I'll just show you, the window that it opens in a separate window, and you get a nice window, Matplotlib animation, nice and easy. And then let's say you want to do if you're still into VPython, and let me see if I can. I'm not even sure. I'm going to try and run this. Okay. Question is whether this is set on Tinker or not. Let's see what happens if I try and run this. Okay, there it is. Let me show you on. So it runs in the Safari browser. This is old. No one uses this anymore, I don't think. But it has some nice 3D animation abilities. So, and going back to Spider, if you want to run something like this is Tinker, and when you run it, up comes like a separate window. If you want to build like a GUI and you don't want to become an expert programmer, you can do some easy things with this. And so this is an example of a Tinker application. I'm not sure it's still live or whether it will work, but let's see if it will work. Start. Yeah. I have to run it again. I'm going to Okay, there it worked. I don't know. Sometimes it works. And then it's all interactive, you know. It's old style, but for physicists, this is all I need to do some of the things I want to show. And then we'll put a new graph on there and everything and so on. So this is a nice window that runs interactively. And I'm going to close it now. I'm going to close my other window. So I'm going to close that bouncing ball. Anyway, so here's some, you know, if you want to start again like I am, some books that I bought. None of them are excellent except for one of them, but I do want to show this. So one of these books, and I will put links into these things later. Python Tools for Scientists. This is a nice book in the sense that it has a pretty decent Python review in there, but it also goes over all the tools. Things like, I wonder what this one is. Okay. Yeah, some of my things are overlapping. I don't know why, but hold on one second. Okay, that's all I wanted to do. Get me back here. So Python Tools for Scientists. It has a, you know, it discusses all the Anaconda system. So you have things like, I'll just show you the short table of contents. You know, it has how to set up your Anaconda encoding environment. And then it has things like, let me go to the longer. Things like setting up Jupyter notebooks, you know, Spider and Jupyter notebooks and JupyterLab and everything. So then it has a Python primer, and then it goes to all the new things on the scientific libraries, SciPy, NumPy, Matplotlib, SymPy, and some of these newer things for videos and neural networks, machine learning, artificial intelligence modules. So I haven't done that. And it goes in detail on NumPy and Matplotlib and Panda, Seaborn, and scikit-learn. So it's a decent book, and I don't know, it costs about $35 and everything. Everything that it has, you could learn online. If you like learning online and going back and forth through links and everything, you don't need these books. But I like books. This is the good scientific learning book because this book, not only does it go, it's more like almost graduate level, but it shows you not so much from the programming point of view, but the examples in here are really nice scientific ones, the type of things you do in advanced undergraduate or graduate school. So he has a book. He goes through the very detailed in the core language and everything, and the plotting and the NumPy and the Matplotlib, a little more detail. But the main thing is that his examples are really, and he's got a web page. I didn't put up his web page. I should have. But he's got a web page where he lists all the. Let me see if I can find his web page. Hold on one second. I have to try and scroll through something. I'm probably not going to be able to find this, but let me try. Well, I downloaded it, but I didn't save his webpage, which I should have. Let's see if I can just find it on the search. Oh, the wrong one. Okay, I think this is it. Okay, this is his web page, and he has all about the book and everything. But each of the book, he's got the chapters. Get the second edition, of course, and but he's got, like, examples, all the examples, and he's got solutions too. If he asks you, but he's going through all kinds of math and physics and everything. It's not just programming. Let's look at the SciPy. He's got, like, problems, and let's say he wants to do a general pendulum and everything. And then you can look at the solution, and he'll have the solution. This is an easy one, but anyway, he's got a lot of advanced. He's got a blog, and as I said, the someone on the Amazon criticized this book because he said, I'm sorry, he said it was too scientific and everything, but it's a book on scientific programming with Python. Anyway, he's got some real good examples. I highly recommend this book. It's interesting reading. Instead of working boring problems, you'll learn things as you do the problems. Another book which is lower level, which I got, this is much lower level, much easier than Hill, but it sort of tries to cover the same thing. And, he has the modules, he discusses Python, then he does NumPy and Matplotlib and symbolic computation and SciPy, all the basic things, 3D VPython. He's the only one I know that still has a chapter on VPython. And then, but what he really has that's interesting for me is that he has about 20 pages on TKINTER. So, and he's got all the programs on his website, and I'm not going to go to his website, but he has all the programs with written out, and you can. When I was showing the Spider module, those were all his programs, so you can look at his code and, like, learn from them how to do TK-inter, and so that's all I have right now. That's what I'm doing. I'll add to the site. So my recommendation, if you've never done any scientific programming or computational physics, would be get the Anaconda, because they have, like, everything you need on Python, and Python has zillions of libraries and modules. If you need to or you want to, get a book or just do it online. Go through that Anaconda with all those tutorials, and get yourself an IDE. I'm trying to use Spider right now. It seems to be working pretty well. I had problems in the past with it, but it's working pretty well right now. And just start doing it. I highly recommend. I may post. I don't want to violate copyright and post Coonan's book. You can get, like, a PDF of it somehow, online and everything. So, hold on, I just want to. So that is my recommendation on how to get started. The thing about programming is that, it's fun and it's feature prone and everything. But Coonan's book, you'll learn some real physics. The other books, you won't really learn that much physics. But one of the things I like about Coonan's book is just that you learn things about Hartree-Fock and quantum scattering and various other things. That's what makes it an excellent book, as well as the teaching you the programming and everything. So thank you for watching, and I'll see you next time. Bye-bye.